Hello dear students, I welcome you all to the second part of tangents and intersecting chords. That is, today we are going to get introduced with exercise 18b. Okay, so before I begin, so let us see the theorems that are going to be useful in this particular exercise. So the first theorem says, if two chords of a circle intersect internally or externally, then the product of the lengths of the segments are equal. Now, in order to understand this, let us take two different diagrams. Alright, here we have got two different cases. One is internal case and another is external. So that's why I'm taking two different cases here. So here I'm taking the internal case. So if you see here, there are two chords, that is AB and CD. Okay, so both AB and CD gets intersected internally, that is within the circle, and the point of intersection is P here. Okay, now let us take the case of external out here. So there's a chord AB and there's another chord CD. Okay, so they do not intersect inside the circle, if you see. All right, so when you produce this, okay, so when you extend this line and this line, then this chord and this chord gets intersected outside the circle. So that's why this is external case, and the point of intersection is again P. All right, so here also the point of intersection is P, and here also we have got the point of intersection to be P. Okay, so in such case, according to the theorem, the product of the lengths of the segments are equal. Now, what is the meaning of this? The meaning of this is, that is this. Okay, so in this chord, that is AB, we have got, in the due to point of intersection, this segment or this chord is divided into two segments. One is AP and another is PB. Similarly, due to this, we have got two segments. One is AP, all right, so this full thing is AP, and another is BP. Okay, so according to this theorem, we should have PA into PB equals to, another is PC into PD. All right, so PC into PD. So please remember this theorem so that we will be able to use this while solving problems. Okay, so the another theorem that we are going to make use out here is this one. Okay, so if a chord and a tangent intersect externally, so this time we are not intersecting the chords, but this time we are intersecting one chord and one tangent, and this time they are going to get intersected externally. Okay, so when they intersect externally, then the product of the lengths of the segment of the chord, okay, is equal to the square of the length of the tangent from the point of contact to the point of intersection. Let's try to understand this. Okay, so there's a chord AB, okay, and there's a tangent PT. So this AB, when extended, gets intersected with the tangent at point P. Now what are the length segments of the chord? One is AP, okay, and another is BP. Okay, so AP into BP must be equals to square of the length of the tangent. So what is the length of the tangent? So length of the tangent is PT. So square of PT is PT square. So basically PT square must be equals to AP into BP. So that's what is the meaning of this particular theorem. All right, and the last theorem which we are already introduced with is called alternate segment theorem. Okay, so alternate segment theorem you are already aware of, right? So according to alternate segment theorem, we should have these two. All right, so you may pause the video to note down each theorem. Okay, so having understood the theorem, let us take few sums from your exercise 18a. So the first question is, in the given figure, in this figure, 3 times CP is equals to PD. Okay, so I can say PD is 3 times CP. Okay, and the length of PD is given to be 9 centimeter. Okay, so PD is given to be 9 centimeter, and AP, okay, so this AP is given to be what? It is given to be 4.5. So you need to find BP. So definitely you have to make use of the first theorem, right? Because there are two chords getting intersected internally, that is within the circle. All right, so in this case what happens is AP into BP is equals to CP into CD, right? Okay, so we have this as AB and CD intersect each other at point P internally. Okay, now do we have AP? See, we are asked to find BP, right? So that is PB. So we will find this, but do we have AP? Yes, we have AP. Do we have CP? No, we don't have CP, but we have 3 times CP given to be 9. So definitely I'll be able to find CP as well. And do we have PD? Yes, PD is also given to be 9 centimeter. So our job is to find now CP, right? So we have 3 times CP, right? So 3 times CP is given to be equal to 9 centimeter. So from here CP turns out to be 9 by 3, which is 3, right? Now we got the value of CP as well. So let us put the values. So AP is 4.5, PB we need to find, CP is 3, PD is 9. So from here if you calculate PB, so PB turns out to be 6 centimeter. Alright, so you may pause the video to note down. Okay, let's move on to the next question. So in this question, in the given figure, we have 5 times PA is equal to 3 times AB equals to 30 centimeter, and PC is equals to 4 centimeter. You need to find CD. Okay, so basically you can see that again AB and CD are 2 chords, but they get intersected externally. So first let's quickly write down the theorem. Alright, so according to the theorem, we must have AP into PB equals to CP into PD, right? So that's what is the theorem. Now do we have AP? So let's see. Yes, AP or PA we can calculate using 5 PA is equals to 30. Okay, do we have PB? No, we don't have PB, right? So we need to calculate PB as well. So where is PB? So PB is this one. Okay, so let us calculate PB as well. Do we have CP? CP or PC? Yes, it is also given. Now do we have PD? No, we don't have PD, right? So PD is also not given. So let us quickly find what are the things given. So we have 5 into PA equals to 30 centimeter, right? So from here PA is simple, it is 6 centimeter, right? So we found PA or AP. Okay, and next thing is we have 3 into AB is equals to 30. So from here what is AB? So AB turns out to be 10 centimeter. Okay, but we don't need AB, right? We need what? We need AP and BP, right? Okay, so we have BP equals to, see here carefully from the diagram, we have BP is equals to AB plus AP, isn't it? So we have AP, right? So do we have AP? Yes, we have AP to be 6 centimeter and we have AB to be 10 centimeter. So we have BP equals to 16 centimeter. 6 plus 10 is 16 centimeter. So we founded our BP as well. So we founded AP, we founded BP, right? Now do we have CP? Yes, CP is given. Now we need to find PD from here. Okay, so we'll find first PD. Okay, and do we have CP? Yes, we have CP, right? So we'll subtract CP from PD in order to get CD. All right. Okay, so put the values and find PD. So PD turns out to be 24 centimeter. Okay, so as I said, CD will be PD minus PC, right? So let us put the values. So PD is 24 and PC is how much? So PC is given to 4. So 24 minus 4 is 20 centimeter. So my answer for this particular question is 20 centimeter. Okay, let's move on to the third question, that is, in the given figure, tangent. So in this case, length of the tangent is given. So definitely this falls under which category? This falls under your third theorem. Okay, so I'm sorry, this falls under your second theorem for the day, that is PT square must be equals to AP into BP. All right, so as I said, we have to use this theorem out here. Okay, now let us see what are the things given to us. Okay, so PT is given, right? So PT we already know. We have PA as well, we don't have PB. So let's quickly calculate PB from here. So just evaluate this. So 12.5 square you have to evaluate by yourself and take this 10 to the denominator. So PB turns out to be 15.625 centimeter. Don't directly copy it, you just have to show how, okay, how you're getting this much. Okay, so your PB turns out to be this much. So PB means this full length, right? Okay, so we are asked to find AB. So AB can be written as PB, and out of PB you remove AP, that is minus AP. Okay, so you have AB equals to PB minus AP or PA. Put the values. Okay, so your answer turns out to be 5.625 centimeter. So you may pause the video to note down. Okay, let's have a look at question number 2. So here we have been given the figure, and in the given figure it is given that AB is the diameter. Okay, so AB is diameter and chord CD. Okay, so AB is diameter and chord CD meets at point P. Okay, and PT is a tangent at T. Okay, so everything can be seen from the diagram. So let us see what are the things that are given to us. So CD is given to be 7.8. So this length is given to be 7.8. PD, okay, so from here to here is given to be 5, and PB, that is, this is given to be how much? It is given to be 4 centimeter. So first we need to find AB. Okay, so let us quickly find AB. Now forget about this tangent, then this AB and CD, right? And so both of them are chord. See, diameter and chord both, see, we can call diameter to be a chord as well. Okay, but we cannot call a chord to be diameter. Okay, so you need to remember that. So that's why if diameter can be considered as a chord, then chord AB and chord CD intersect each other externally at point P, right? So please forget about this tangent. So we can say that PA into PB is equals to PC into PD. All right. So using that, we'll calculate what is our AB. So we have, as I said, right, so we have this formula with us. So let us see what are the things that are available with us. So do we have PA? No, we don't have PA. Okay, so do we have PB? Yes, PB is there. Do we have PC? PC is also not there. So we need to calculate PC as well, and PD. Yes, so we have PD. Okay, so we know that PA. Okay, so PA, this whole distance can be written as BP plus AB, right? Okay, so BP plus AB, it can be written. Now we don't know AB, that's what we need to find, right? But we know BP or PB, which is given to you 4. So that's why this can be written as AB as it is. We don't know the value, and instead of BP I have written 4. All right, so this is the value of my PA. And we have PC. So PC can be written as PD plus CD, right? And we know the value of PD and CD both, right? So what is PD? PD is given to be 5, and what is CD? CD is given to be 7.8. So let us put the value, then after adding I'll get 12.8 centimeter. Now let us put the values out here. So PA can be written as AB plus 4 into PB. PB is 4, PC is 12.8, and PD is 5 from here. Okay, so when you simplify this, okay, so just simplify this 4 goes to the denominator, and when you simplify you'll get 16. Okay, so take this 4 out there, so you'll get AB to be 12 centimeter. Okay, so this is our first answer. Now next is we need to find the length of PT. Okay, so forget about any one of the chord. Okay, either you can forget AD or you can forget about chord CD. So for now let me forget about chord AB. Then there are 2 lines, one is CD and another is PT. So basically what is happening here, this chord CD meets the tangent PT at point P. So we can say that this PT square is equals to PC into PD. Yes, so we have PT square equals to PC into PD. So do we know PC? Yes, we know PC, right? So PC is equals to 12.8, and do we know PD? Yes, so we know PD as well. So when you put the values and multiply, you'll get 64. That means PT square is 64. So what is the value of PT? So PT will be square root of 64, which is 8 centimeter. So you may pause the video to note down. Okay, let's move on to question number 3. In the following figure, that is this figure, PQ is a tangent, so you can clearly see that PQ is a tangent at A. DB is the diameter, so DB is given to be the diameter, and O is the center. Okay, so if angle ADB, so let us say ADB, so ADB is given to be 30 degree, and CDB is given to be 60 degree. So we need to calculate these 3 angles here. Okay, so let us see first angle, that is QAB. So we have QAB means we need to calculate this angle, right? Okay, now if you see here, this angle is being formed by chord AB and this tangent, right? So can we make use of alternate segment theorem? Yes. Okay, so this is the tangent, oh, this is the chord and this is the tangent. So we have to look for one angle which is formed in the alternate angle, so alternate segment, sorry. So this is the line, this is the chord, so alternate segment becomes this, right? So in this, AB is making angle ADB, isn't it? So can I say that this angle and this angle will be equal? Yes. So we can say that this angle and this angle, they will be equal, that is angle QAB, that is this angle is equals to angle ADB. Okay, why? Because they are angles in the alternate segment. So we know the value of ADB, which is given to be 30 degree. So that's why my QAB will be 30 degree here. Okay, so we found the first answer. So the next question is PAD. So let's see where is PAD. So we have got PAD. Okay, so see here carefully. So we have got PAD. So basically we have to find this angle here. Okay, now if you see here carefully, this is the tangent and this line is called the radius. They will be perpendicular to each other. That means this full angle is going to be 90 degree. So if we are able to find this angle, that is OAD. Okay, so after finding this, if I subtract this angle from 90 degree, then I'll get this angle, isn't it? So that's what I'm going to do out here. Okay, so as it is given that OA and OD will be equal because they are radii of the same circle. OA and OD are the radii, so that's why these two will be equal. Now, so we have OAD is an isosceles triangle, right? So in isosceles triangle we have two sides equal and together with it we have got two angles equal. So that's why this angle is 30. So this also has to be 30 degree. Okay, so that's why OAD, angle OAD will be equals to 30 degree. Okay, fine. Now we founded this angle. So as we know that OA is perpendicular to PQ, that means this full angle is 90 degree, right? So that's why we have PAD can be written as this full angle, that is PAO minus this angle, that is OAD. Alright, so that's what is done here. So what is the value of OAP? So OAP means this full angle, so this full angle is 90 degree, right? And OAD, just now we found it to be 30 degree. So the answer for angle PAD will be equals to 60 degree here. Okay, fine. So let's move on to the last part, that is CDB. So let us see where is CDB. So CDB means we have to calculate this angle here. Okay, fine. Now since DB is the diameter, then this part is your semicircle, isn't it? And angle C is the angle formed in the semicircle, right? So that's why this has to be 90 degree. We already know this is 60. So obviously then this has to be 30 degree in order to make the sum of the interior angles of this triangle to be 180 degree. Okay, so as BD is the diameter, we have angle BCD equals to 90 degree. Okay, because this is angle in a semicircle. Fine. Okay, so in triangle BCD, so in this triangle BCD, then we know that some of the interior angles will be 180 degree. So let us put the values. So CBD means this angle is given to be 60 degree, right? So it is already given. BCD, just now we saw that this will be equals to 90 degree and we are asked to find CDB, right? So we need to calculate CDB. So from here you calculate your CDB and this turns out to be 30 degree. All right, so you may pause the video to note down. Okay, let's have a look at question number 4 here. So there's a figure directly given to you, so let us directly understand the question here. So we need to calculate PRS. Okay, so PRS means we need to calculate this whole angle out here. Okay, and next is we need to calculate ROT. Okay, so ROT means we need to calculate this angle out here. Okay, so we'll calculate these two, and what is given to us? TRQ is given to be 30 degree. So that is this angle is given to be 30 degree out here. Okay, so let's begin. Okay, so we need to calculate PRS, right? So PRS means this angle, and what is this angle? This angle is formed by this tangent and this chord, that is SR. So basically you are using a chord and tangent, so that's why you can make use of something called alternate segment theorem. Okay, now this chord is there and this chord divides the circle into two segments. One is this segment and the rest of the part. All right, so since you are measuring in this segment, you have to go to alternate segment, that is in the rest of the circle. Okay, and in the rest of the circle, this SR is making angle, this one, right, that is STR, right. So basically here if I use alternate segment theorem, then I can say that this angle and this angle, they will be equal. So that's why first let me find how much is this angle out here. Okay, so we know that PQ is the tangent and OR is the radius, right. So PQ is the tangent and OR is the radius, so that's why they will be lying, or I can say that OR is perpendicular to PQ. That means this full angle is how much? This full angle is 90 degree. So will we be able to find this angle? Yes. So just you need to subtract this 30 from 90 degree in order to get this angle, right. So that's what I'm going to do out here. So we have TRO. Okay, so this is TRO, not TRQ. Okay, so this angle is TRO. Okay, so TRO is equals to, as I said, this 90 degree minus this. Okay, that is 30. So this turns out to be 60 degree. Now let's have a look at this triangle. So in this triangle, we see that OR and OT, they are radius, right. So that's why they will be equal to each other. So that's why this is again isosceles triangle here. So in isosceles triangle, we have two angles again equal to each other. So that's why this angle will also be equals to how much? 60 degree, as this angle is 60 degree. All right, so that's why we have, okay, so that's why we have, as I said, this angle. Okay, so OTR, or you can call it STR as well. Okay, so this will be 60 degree. Okay, so therefore I can say PRS. Okay, so PRS means this angle will be equals to this angle, that is STR. Why? Because they are angles in the alternate segment. All right, and how much is STR? Just now we showed that STR is 60 degree. So that's why my angle PRS will also be 60 degree. So this is my first answer. Now next is ROT. Okay, so ROT means we need to calculate this angle. Now we know this angle, we know this angle, so definitely we will be able to find this angle. All right, so let me quickly show this. Okay, so this will turn out to be 60 degree. You will be able to find the third angle by yourself. All right, so this also turns out to be 60 degree. So you may pause the video to note down. Let's move on to the next question. So in this question, again the diagram says everything, so let's not go into the detail of the question. So just see what we need to show. So we need to show that BC and BD are equal. Okay, so first and foremost, let's join OC. Okay, so it's already joined here. So now, so in order to show that BC and BD are equal, basically what we are going to do is we'll just show that this BCD is an isosceles triangle. That is, if we are able to show that this angle and this angle are equal, then we say that this is isosceles triangle, and if this is isosceles triangle, then BC and BD will automatically become equal to each other. All right, okay, so let us first find how much is this angle. Okay, so this angle is formed by chord BC and tangent CD, right. So we will search for alternate angle in the alternate segment. Okay, so in this segment we need not find any angle. So in the rest of the circle, CB is making angle CAB, right. So I can say that 30 degree and this angle will be equal to each other using alternate segment theorem. So that's why I am saying angle BCD. Okay, so angle BCD is equals to 30 degree out here. All right, okay, so we found this angle. Now let us show that this angle is also 30 degree. Okay, so before that, Forget about this tangent. Okay, so forget about this tangent and let's have a look at only the circular part. So in this circle, if you see arc BC makes angle BOC with the center, isn't it? And in the rest of the circular part, again BC makes angle BAC. So that's why I can say that this angle will be just half of this, isn't it? So this theorem we have learned in our circle chapter. So as I said, arc BC is often DOC. Okay, so DOC, or you can say BOC as well. So DOC means this angle and BOC also means the very same angle. Okay, so arc BC subtends DOC at the center and BAC at the remaining part, right? So BAC at the remaining part of the circle. So that's why I can say angle BOC. So it's better that you write BOC out here instead of DOC. All right, so BOC. So this angle will be double of this. All right, so from here we get BOC. Okay, so the value of BAC is how much? 30. So that's why 2 into 30 becomes 60. So that's why this angle will be 60 degree out here. Okay, fine. So let's observe this triangle now. So we have got triangle OCD. All right, so we have got this triangle with us. Now this angle is equals to 90 degree out here, right? Isn't it? Because the CD is the tangent and OC is the radius. So that's why this angle will be exactly 90 degree and we know that this is 60 degree. So definitely we will be able to find this angle as well here. All right. So this has to be exactly 30 degree, right? Because this is 60 and this is 90. So 60 plus 90 is how much? 120. So obviously this has to be how much? Okay, so I'm sorry, this is 60 and this is 90, so altogether this is 150. So obviously this has to be 30 degree. All right, so that's what is written out here. Okay, so this also turns out to be 30 degree. Is that clear? Okay, so we showed that this is 30 and this is also 30. So that means in BCD, triangle BCD, we have got two angles to be equal to each other. So that's why this has to be isosceles triangle. All right, so both are 30 degree as I said. So BDC and BCD both are 30 degree. So that's why we must have BC and BD to be equal to each other. So you may pause the video to note down. Okay, let's move on to the sixth question. Tangent at P to the circumference of a triangle PQR is drawn. Okay, so there's a triangle PQR and you have to draw a circle. Okay, and to that circle you are drawing a tangent. Okay, and here from the diagram we see that DE is the tangent out here. Okay, now if this tangent is parallel to side QR, that means this DE is parallel to QR, we need to show that PQR is an isosceles triangle. Now what is the meaning of that? So in isosceles triangle we need to show that any two sides are equal to each other. All right, so that's what we are going to prove out here. So please remember what is given to us. Given is DE is parallel to QR. So whenever we see two lines being parallel, we search for something called transversal as well. So there are actually two transversals. One is PQ and another is PR, right? So if you look at only PQ, then you will get a pair of alternate angles here. Okay, so you look for Z type of figure. So we clearly see that there is a Z out here, right? Okay, so this angle and this angle, they are alternate angles here and they will be equal to each other. Similarly, if you consider PR as your transversal, then again you see a Z kind of figure here, right? So again this angle and this angle, they becomes your alternate angles and they will be equal to each other. All right, so that's what is said out here. All right, so EPR, so EPR, that is this angle, will be equals to PRQ, that is PRQ, that is this angle. Similarly, we have DPQ, that is this angle, will be equals to PQR, that is this angle. Okay, hope this thing is clear to you. Okay, so that's all about your these two lines being parallel. Now let us see what kind of angle is this. Now we know that PQ is what? PQ is a chord, right? So PQ is a chord and DE is the tangent. So this is the angle being formed in between the chord and tangent. Okay, so whenever we see such kind of case, we always look for the alternate segment out here, right? So we have to go to this segment out here. All right, so because PQ is making two segment, one is this smaller segment and the rest of the part of the circle. Okay, so we don't look for any angle in this segment, we have to go to another segment. All right, so in another segment, this PQ is making angle PRQ, right? So that's why I can say that this angle and this angle, they will be equal to each other, right? So we have D is the tangent and PQ is the chord. So that's why we have DPQ, that is this angle will be equals to PRQ, right? That is this angle. Why? Because they are angles in the same segment. All right. So let's make use of this equation 1, that is these two and this one. Okay. So if you see here, what is happening? So it says DPQ and PRQ are equal, right? So DPQ and this one, they are equal. So what is the meaning of this? Then this and this must also be equal, right? All right. So we have, so from 1 and 2 we have PR, or in other words, if these two are equal, then this is equal to this and this is also equal to this. So all these four angles are equal to each other, right? So out of these four, I am interested with only two angles. Okay, so one of the angle is PQR, okay, and another is PRQ. Why am I interested with only these two angles? Because these two angles are inside the triangle, right? So I showed that this angle and this angle are equal. So that's why if these two angles are equal, then the opposite sides, that is this and this, automatically becomes equal to each other. So basically in this triangle, two sides are becoming equal to each other. So what is the meaning of that? This means that the triangle PQR is isosceles triangle. So you may pause the video to note down. Let's move on to the next question, 7th question. So two circles with center O and O dash. So this blue circle is having center O, and this bigger one, that is yellow circle, is having center O dash. Okay, so they intersect each other at point A and B. So A and B are the point of intersection of the circle and yellow circle. Okay, now center O of one of the circle, okay, center O lies on the circumference of the other circle. Now see, O is lying on the circumference of this circle, isn't it? Okay, and it is said that CD is drawn tangent. So CD is the tangent to the circle with center O dash. So CD is the tangent to the circle with center O dash at where? At A. So at A, CD is the tangent. So we need to prove that OA bisects angle BAC. So let us see where is OA. So OA means this angle, this line bisects which angle? That is BAC. So BAC. So OA bisects BAC means this angle, this smaller angle. All right, so this small angle, that is OAC, and this angle, that is OAB. They are equal. That's what we need to show out here. So let's begin here. Okay, so we have got some construction to do out here. So the construction is to join AO dash and OB dash. All right, so these are the different constructions that are done in this particular diagram. Okay, so we see that CD is the tangent, right? CD is the tangent and AO is the chord, right? And as we need to find this angle, so we have to make use of again alternate segment theorem. Okay, so I am looking for only this smaller circle. All right, I'm sorry, this bigger circle. Okay, in the bigger circle, AO is the chord, right? So only in the bigger circle. So AO is the chord and CD is the tangent. So this angle, okay, will be equals to, now let us see, AO is making which angle in the alternate segment, that is in the remaining part. So obviously this makes ABO angle, right? So this angle ABO and OAC will be equal to each other because they are angles in the alternate segment. Hope this thing is clear to you. Okay, very good. So we found it, this angle. Now let's have a look at this triangle, that is OAB. All right. So if you see this OAB, we have OA and OB equal to each other. Why? Let us see. So, OA is the radius of smaller circle, isn't it? Similarly, OB is the radius of smaller circle. So, that is why I can say that they are radii of the same circle. So, that is why this and this are equal to each other. That means this is what kind of triangle? This is isosceles triangle, and in isosceles triangle this angle and this angle, they will be equal to each other. Alright. Okay. So, if you see here, this angle is equal to this and this angle is also equal to this, right. So, if I compare these two, 1 and 2, what is the meaning of this? This angle and this angle must be, I am sorry, this angle and this angle must be equal to each other, right. So, we have OAC, this angle is equals to OAB, that is this angle. So, what is the meaning of this? This means that OA is acting like a bisector of BAC, right. So, that is why I say OA is the bisector of angle BAC. So, you may pause the video to note down. Okay, let us move on to the last question of the day. So, question says, two circles touch each other internally. So, you can clearly see from the diagram. So, there are two circles which touch each other internally. At which point? At point P. Now, a chord AB of the bigger circle. So, AB is the chord of bigger circle, as you can clearly see from the figure. But this AB cuts the smaller circle as well, right. So, a chord AB of the bigger circle intersects the other circle, that is smaller circle, at C and D. So, at C and D, AB is intersecting the smaller circle. So, we need to show that CPA. So, let us see where is CPA. So, CPA means we need to show that this angle and DPB. So, DPB means this angle. So, this angle and this angle, they are equal, that is what we need to show here. So, before that, let us construct one tangent out here, alright. So, the name of the tangent is TPS, okay. So, let us draw TS, tangent TS at point P, okay, fine. Okay, so, we have TPS is a tangent, right, and PD is a chord, isn't it? Hope this thing is clear to you. So, TPS is a tangent and PD is a chord. So, we have PAB. So, let us see where is PAB. So, PAB, that is this angle, okay, will be equals to BPS, that is BPS, okay, that is this angle, okay. Now, see here carefully. So, this angle will be equals to this angle, alright. So, actually this is not PD, please make the correction, this is PB, okay. So, PB is this chord and this is tangent, and you want to evaluate this angle, right. So, chord PB and tangent is making this angle. So, we have to go for not this segment, I am looking for a bigger circle, okay. So, in the rest of the bigger circle, this PB is making angle PAB, right. So, this PAB and this angle BPS will be equal to each other because they are angles in alternate segment. So, let me call this as equation 1, okay. Similarly, we can show that PCD, alright. So, PCD means this angle and DPS, that is DPS, they will be equal. So, you will be able to show using the same technique, that is they will be the angles in the alternate segment, okay. So, let us have a look at triangle PAC. So, we have got triangle PAC here. So, PAC. So, we are talking about the small triangle out here, okay. So, in this triangle, this is the exterior angle, that is PCD is the exterior, right, and we know that this exterior will be equals to sum of the opposite interior. So, what are the opposite interior out here? So, if this is my angle, then opposite interior are this and this, right, that is PAB. So, PAB means this angle, right, PAB means this angle, and CPA. So, CPA means this angle. Hope this thing is clear to you. Now, what is PCD? PCD is equals to DPS, isn't it? Okay. So, instead of PCD, I am writing DPS. And what is PAB? PAB is BPS, right? Okay. And we have CPA as it is. Now, let me take this BPS out here. So, becomes DPS minus BPS, okay, will be equals to CPA. Now, what is DPS minus BPS? Let us see. So, DPS is this full angle, alright. And next is BPS. So, BPS is this angle. So, basically from this whole angle you are subtracting this angle. So, you will get only this angle, isn't it? And what is the name of this triangle? This is DPB. So, basically this full thing is DPB, right. So, DPB is equals to CPA. So, that is what we need to show out here, right. So, that is why I am saying CPA is equals to DPB, alright. So, you may pause the video to note down. So, with this we close the half of the exercise 18B. Thank you very much.